and velocity. Before understanding about speed and velocity, let us first understand in brief about vector and scalar quantity. A physical quantity having magnitude as well as direction is called vector quantity. On the other hand, a physical quantity having only magnitude is called scalar quantity. Velocity and displacement are vector quantities, while distance, speed, and time are scalar quantities. Let us now study about speed and velocity. The distance covered by an object in unit time is called speed. Speed is equal to total distance traveled upon total time taken. The distance traveled in particular direction by an object in unit time is called its velocity. The unit time could be 1 second, 1 minute, 1 hour, etc. If large units are used to measure time, 1 year can also be used as a unit of time. The displacement that occurs in unit time is called velocity. Velocity is equal to displacement upon time. Always remember, the units of speed and velocity are the same. In the SI system, the unit is meter per second, while in the CGS system it is centimeter per second. Speed is related to distance, while velocity is related to displacement. If the motion is along the straight line, the values of speed and velocity are the same. Otherwise, they can be different. Let us calculate speed and velocity with the help of the information obtained from one of the examples of displacement and distance studied earlier. In this example, the straight line distance between the houses of Sheetal and Sangeeta is 500 meters. The straight line distance between Sangeeta's house and school is 1200 meters. Also, the straight line distance between Sheetal's house and school is 1300 meters. Sheetal took 5 minutes to reach Sangeeta's house, and from there she took 24 minutes to reach school. Come, let us determine Sheetal's speed and velocity using this information. Sheetal's speed along path A equals to distance upon time equals to 500 meters divided by 5 minutes equals to 100 meters per minute. Sheetal's speed along path B equals to distance upon time equals to 1200 meters divided by 24 minutes equals to 50 meters per minute. Sheetal's average speed equals to total distance upon total time equals to 1700 meters divided by 29 minutes equals to 58.6 meters per minute. Sheetal's average velocity equals to displacement upon time equals to 1300 meters divided by 29 minutes. That is, Sheetal's average velocity is 44.83 meters per minute. After understanding about speed and velocity, let us now study the effect of speed and direction on velocity. Effect of speed and direction on velocity. Let us study the effect of speed and direction on velocity with the help of an example. Sachin is traveling on a cycle. Let us see what happens during his ride at certain points. During his ride, Sachin first increased the speed of the cycle without changing its direction. Due to this, the velocity of the cycle increased. Then, he decreased the speed of the cycle, which decreased the velocity too. After traveling some distance, there came a turning on the road. At that time, there was a change in the speed as well as velocity of the cycle. Later, Sachin kept the speed of the cycle constant and changed the direction. Even at that time, there was a change in the velocity of the cycle. Then, while riding the cycle on the turning, Sachin changed the speed as well as the direction. Even at that time, there was a change in the velocity of the cycle. On observing all these events, it is clear that velocity depends on speed as well as direction. Thus, velocity changes by changing the speed while keeping the direction same, changing the direction while keeping the speed same, changing the speed as well as direction. Always remember, the first scientist to measure speed as the distance upon time was Galileo. The speed of sound in dry air is 343.2 meters per second, while the speed of light is about 3 into 10 raised to 8 meters per second. The speed of revolution of the Earth around the Sun is about 29,770 meters per second. Let us now proceed further.